Welcome back to another tutorial. Today, we'll be making Tapping Pong by Joshua TNT Gamer. This is a one-tap game originally created as a submission for Fan Week, which is an event that I actually facilitate. You can check out the compilation for the particular edition this game is in once you finish this video. This game is essentially Pong, but you control the ball. Your goal is to bounce yourself off the paddles without straying off the scene. If you're looking to create a more traditional game of Pong, then you can check out the tutorial I made a couple of years ago. Anyways, let's get started. So we have a blank level. You might notice some unusual blocks at the hotbar. Don't worry, I'll address them later. For now, let's focus on our assets. We only need to make two objects, a red block for our ball and paddles, and a smaller red block for the particles. I'll make the normal block out of a box to get that boxy collider. To check if that's the case, we can simply click the gear icon below. For our tiny block, let's bring out a particle and paint it red. If we press the gear icon, you can see that it has no collider. We'll also use a vector lerp and a number lerp, which allows us to easily smoothen up our values. These are custom script blocks located inside Fanscripts by Sonoc. First, let's bring out a script block to house all of our assets. We'll bring in a play sensor to have it only run once. And for our paddle, let's make it 5 blocks long to have a decent size. Then, we'll duplicate it. We could save this in another variable with a different name, but we could actually store both of these paddles in a single list and use their indices to refer to them later. Our first paddle has an index of 0, so we don't really need to use a list block, but for our second paddle, however, we'll set the index to 1. Then, we'll only use a single block for our ball and a small block for the particle. Afterwards, let's grab another script block for our main code. We'll start by initializing our origin point. For now, let's have it somewhere close, like 3 blocks away. Then, let's set the visibility of our ball to true to show it in our game, as well as update its position to be at O. Then, we need to initialize our paddles. Since they're both stored inside the list, we can actually bring out a loop that runs twice to go through them. From here, we'll reveal our object by setting its visibility to true. For the position, let's quickly talk about how we'll manage to place them. What we want is to have a paddle on the left side and a paddle on the right side. Therefore, we'll be using our loop index to help us with that. Because our index goes from 0 to 1, what we can do is subtract that value by 0.5 and multiply it by 2. Thus, we convert 0 to -1, but 1 remains the same. So we now have a negative number and a positive number. Therefore, if we scale it to the x position of a vector, the first index moves it to the left, while the second moves it to the right. We'll use our origin point and add a vector to it, which will be scaled using our index. And as you can see, our paddles are now situated at either side of the ball. Finally, let's keep track of their positions via a list. Let's also set up the camera for our game. For the distance, let's keep it close right now, so I'll set it to 30. And we want a top-down view for our rotation, so I'll change the x value to 90. Then, for our position, we can simply attach our O variable. We'll also set up the lighting to have the same rotation as the camera to remove the shadows. The next step in our process is to work on the controls. The original game has extremely simplified gameplay, when we can simply tap the screen to change the vertical direction of the ball. First, we'll set up an if statement that checks if the game has stopped. Then, let's bring in a touch sensor with its mode set to begins. Once the play has touched the screen, we'll connect the wire to another if statement to determine if the game has started. If this returns false, which it would as the default value of a boolean is false, then we'll set it to true to have it only run once. In the original game, the camera zooms out once the game has started, And to achieve this effect, we'll be tuning the value of our camera range. Let's add a new variable, CG, which stands for camera goal, and set it to 60. We'll go back to our camera script and attach a play sensor to initialize our range values. At the start of the game, we want both our camera range and the camera goal to have the same number to make our camera static. So let's go ahead and do just that. Afterwards, we can update the value of cam with a number lerp, which is one of the custom blocks we'll use in our game. I'll set cam as our starting point, CG as our endpoint, and have the amount at 0.125. Let's quickly check if this works, and it does. Once we've tapped the screen, the camera zooms out. Next, we need to add two variables to move our ball. The first one is the direction, which determines where our ball is pointing, and the second one is the speed, which determines how fast our ball traverses. We'll initialize the values at the start, and you can decide which direction the ball is going to go towards, as long as it's a diagonal, meaning you should have a value of either 1 or -1 in both the X and Z positions. And for speed, I'll set it to 0.04 to start things slow. Then, let's update the position of our ball, which we'll only want to run once the game has started. We'll take the original position of the object and add our direction to that, which is scaled by our speed. And if we press play, you can see that our ball is moving down and right. Let's return to our controls. Once the start boolean is true, we can change the vertical direction of our ball by using the negate block. This block is pretty straightforward, all it does is invert the value of a number. So for instance, if we have a 1, plugging into this block gives us -1. And if we have a -1, this block will return with a 1. We'll top it all off with a click sound effect. Let's now focus on implementing the collision for our ball. It's pretty simple, all we really need to do is to set up a raycast. For the starting point, we'll stamp from the paddle's position and shift to the left, which is where the ball would probably be. Then we'll go downwards, and for the endpoint, we'll move up. However, this only effectively checks for anything at the upper side of the paddle, so we'll have another raycast, but this time we'll shift upwards and have it point down. We'll be checking for a ball using whichever paddle is active, which we can easily determine by bringing in a new variable to keep track of our score and have a modulo of 2. What this does is limit our values between 0 and 1, which are the indices of our paddles. And from here, we'll add an offset to our position. We'll take our number and subtract by 0.5 to get those positive and negative signs. Then we'll multiply it by how far away our raycast should be from the paddle. I'll set mine to 1.05. Then let's bring in our raycast. For our starting point, we'll take vec and add a variable as an offset. And for our endpoint, we'll subtract our starting point with some vector variable. For v2, we'll have a positive number since it's being subtracted, therefore it will go down. I'll set it to 5.25. Then for v1, it's important for the value to be half of v2 to equally cover the paddle side, and the half of 5.25 is 2.625. Next, we'll duplicate these values and attach it to the rest of our script. This allows us to run our raycast twice. Then, I'll negate these values to account for our second line, which goes down then up. And if we press play, you can see that our raycast is at the wrong paddle. Why is that the case? Well, if we head over to where we initialize the paddles, you can see that the vector being scaled has a positive number. Because the index of our first paddle is 0, which is eventually converted to -1, this moves the object to the left. To fix this, we can just change the value to -2 to have them go the other way. Once the raycast has detected something, then we'll play some ball and beep sound effects, increase the score by 1, and change the horizontal direction of our ball by negating the x value. And as you can see, our ball is now bouncing back and forth. However, this seems pretty boring because nothing is really happening. Therefore, the next thing we should do is to move the current paddle. We'll bring in P, which monitors the paddle's position, and change its value. Again, we can get our active paddle by using score and a modulo of 2. We'll start with our origin point and add an offset from that. Let's make a vector and set our x position. We'll subtract our number by 0.5 and multiply it by how far the distance it should have from O. Again, since our score is now at this point, it now refers to the second paddle, which is at the left. Therefore, we would want to move it even further, so we'll use a negative number. And for the z position, let's use a random number that goes from -4 to +4 using a negate block. We also need to update our paddles to see those changes. So we'll have a loop that runs twice and set the position for objects. Let's use the vector loop to have a smooth movement, with our original position as the starting point, P as the endpoint, and 0.125 as the amount. Now our paddles are moving every time the ball bounces, but right now it still is kinda boring as our speed is pretty slow. So let's pan towards where we set P and increase the speed. Let's have it go up by 0.005 every time a collision happens. However, we would want to put a cap on this as at a certain point it would be physically impossible to anticipate the ball due to its speed. And for this, we can use a min block. What this block does is get the lower value from its two inputs. So if one has a 2 while the other has a 3, then the block returns the 2. We can use this to our advantage by connecting our speed and our limit. At the early game, our speed will obviously be below our limit, so it will slowly increase. But once there comes a point where it passes our limit, the block will now get the value of our cap and effectively stop our speed from going up. I'll set the limit to somewhere around 0.2, and if we press play, we might probably not notice the speed at first, but eventually it starts to pick up and become faster. Now let's code what happens if the player loses. Our losing condition for this game is if the player failed to catch the ball in time, as it moves away from both our paddles. We'll have an if statement to have this code execute if the game hasn't stopped, and we could use the distance block to check how far away our ball is from the origin point, but we're only really looking for its x value. Therefore, what we can do is subtract our position by O and break its vector. From here, we can use the absolute block to turn our x into a positive number. Then we can check if it's less than, say, 4. And if it is, then we'll set stop to true to disable our code, and attach a loose block and set the delay. And if we press play, once the ball has escaped the paddle, we trigger the lose condition. Let's also add a little bit of pizzazz to our game by implementing a simple particle system. The gist is to create a copy of our particle block and place it somewhere around our ball. Then once enough frames have passed, we delete the copy. We'll begin by having an if statement to ensure that this only runs once the game has started. Then we'll use the create object block to generate a copy of our particle. We then insert it to a list as well as update its position. We'll take our ball's position and add an offset with randomized values for x and z positions. We'll set this number to something low like 0.25. Finally, let's increment the list length. Right now, it clones our particle every frame, but since we haven't added any code to delete them, this will quickly slow down the game's performance over time as we have too many objects. So we'll bring in a loop and use mslen to go through all of our copies. We'll start by checking if this object exists via an equal objects block, and if this returns false, then that means it corresponds to an existing object in the scene. If that's the case, then we'll use a list to be our timer. We'll check if it's greater than 30, and if it isn't, then we increase its value. Once it inevitably reaches that point, then we delete our object. And as you can see, our particles dissipate once 30 frames have passed. Then let's also display our score by using a set score block, though we only want to show it once the game has started. If we leave the edit mode and play the game normally, you can see the script blocks. Because we haven't actually placed any object in the scene apart from them, they will show up in our game instead. What we can do to fix this is to bring in a normal block and hide it. If we return and play it again, it also hides our scripts. That's it for this tutorial. I hope you learned something out of this video. As always, you can click the GitHub link in the description to take a look at the code in case you got stuck at something. Anyways, I'll see you at the next one.